The 17th century witnessed a revolution. It was a revolution of the mind. At the forefront of this revolution stood Isaac Newton. He was a beacon of reason in an age grappling with superstition. Newton's insights illuminated the workings of the universe. His work laid the foundation for modern science. Newton's impact extends far beyond his time. His laws of motion govern the movement of objects both on Earth and in the cosmos. His discovery of calculus revolutionized mathematics and physics. His work in optics transformed our understanding of light and color. Newton's legacy is not confined to textbooks and laboratories. His ideas permeate our daily lives. From the cars we drive to the smartphones in our pockets, Newton's principles are at work. His influence is a testament to the power of human curiosity and the enduring impact of scientific discovery. Isaac Newton's life was marked by both triumph and adversity. Born in 1643 in Woolsthorpe, England, he entered a world on the cusp of change. His childhood was far from idyllic. He was a premature baby, not expected to survive. His father, a farmer, died just 3 months before his birth. Newton's early education was unremarkable. He attended the King's School in Grantham, where he showed an aptitude for mathematics. At the age of 19, he entered Trinity College, Cambridge. It was here that his genius began to flourish. Cambridge provided Newton with an environment to explore his intellectual curiosity. He immersed himself in the works of Galileo, Kepler, and Descartes. These intellectual giants ignited a passion within him. He questioned accepted theories and began to formulate his own. His time at Cambridge laid the groundwork for his groundbreaking discoveries. Newton's contributions to science are vast and profound. One of his most significant achievements was the development of calculus. This new branch of mathematics provided tools to describe motion and change in a precise and powerful way. It revolutionized fields like physics, engineering, and economics. Equally groundbreaking were Newton's 3 laws of motion. These laws, published in his masterpiece, Philosophiae Naturalis Principia Mathematica in 1687, provided a framework for understanding the relationship between force, mass, and motion. They explained why objects fall to the ground, why planets orbit the sun, and why projectiles follow a curved path. Perhaps Newton's most famous discovery was the law of universal gravitation. This law states that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. This simple yet elegant equation explained the tides, the orbits of planets, and the very structure of the universe. Newton's curiosity was not limited to the heavens. He also made groundbreaking discoveries in the field of optics. In a series of experiments, he demonstrated that white light is composed of a spectrum of colors. He used a prism to split white light into its constituent colors and then recombine them to form white light again. Newton's work in optics led to the development of the reflecting telescope. This new type of telescope used mirrors instead of lenses to focus light, which greatly improved image clarity. The reflecting telescope revolutionized astronomy and is still used today to explore the depths of space. His understanding of light and color had far-reaching implications. It influenced art, design, and our understanding of vision itself. Newton's work in optics demonstrated his ability to make groundbreaking discoveries across multiple scientific disciplines. Section 5. Destination Moon. Newton's physics in space travel. Centuries after his death, Newton's laws remained fundamental to space exploration. Launching rockets, navigating spacecraft, and landing on other celestial bodies all rely on his principles of motion and gravity. Understanding the forces involved in space travel is crucial for mission success. Consider a rocket launch. Newton's 3rd law of motion, which states that for every action there is an equal and opposite reaction, explains the thrust that propels a rocket upward. The burning fuel creates hot gas that is expelled downward, generating an equal and opposite force pushing the rocket upward. Similarly, calculating trajectories for spacecraft to reach the Moon or Mars requires a deep understanding of Newton's law of universal gravitation. The gravitational pull between celestial bodies determines the path a spacecraft must take to reach its destination. Section 6. The Architect of the Cosmos, Newton's Enduring Legacy. Isaac Newton's later years were marked by continued intellectual pursuits and recognition for his groundbreaking work. He became president of the Royal Society in 1703, a testament to his standing in the scientific community. His contributions to science had a profound impact on the way we understand the universe. Newton's legacy extends beyond his specific discoveries. He established a new way of thinking about the natural world. He emphasized observation, experimentation, and mathematical reasoning. This approach became the foundation of the scientific method, which continues to guide scientific inquiry today. His work inspired generations of scientists and thinkers. He showed that the universe is not a realm of magic and mystery, but rather a place governed by laws that can be understood through reason and observation. This shift in perspective marked the birth of modern science. Section 7. Newton in our gadgets, the ubiquity of his laws. While we may not always realize it, Newton's laws are at play in our everyday lives. From the simple act of walking to the complex workings of modern technology, his principles are constantly in action. Take, for example, the design and function of a smartphone. The touchscreen responds to the pressure of our fingers, a concept related to Newton's laws of motion. The internal accelerometer, which detects the phone's orientation, relies on these same laws to determine how to display the screen correctly. Even the GPS navigation system in our cars or phones depends on Newton's theories. GPS satellites orbiting Earth rely on his law of universal gravitation to maintain their orbits. Section 8. Beyond the telescope calculus in the digital age. Calculus, the mathematical language Newton invented, has become an indispensable tool in the digital age. Its applications extend far beyond its original use in physics and astronomy. In computer science, calculus is essential for tasks such as image processing, data analysis, and machine learning. Algorithms used in search engines, social media platforms, and online shopping sites all rely on concepts from calculus. Furthermore, fields like finance and economics use calculus to model market trends, predict stock prices, and manage risk. Its ability to analyze change and motion makes it a powerful tool in understanding complex systems. Section 9. Whispers of light, from prisms to fiber optics. Newton's work in optics continues to have a profound impact on modern technology, particularly in the field of telecommunications. His experiments with prisms and the nature of light laid the groundwork for technologies like fiber optics. Fiber optic cables, which transmit data as pulses of light, rely on principles of reflection and refraction that Newton first explored. These cables form the backbone of the Internet, enabling high-speed data transmission across the globe. From video streaming to online gaming to instant communication across continents, our digitally connected world is built upon the foundation laid by Newton's discoveries in optics. Section 10. Conclusion: Newton's timeless impact on humanity. Isaac Newton's impact on science and human thought is immeasurable. His contributions continue to shape our understanding of the universe and drive technological innovation. From the laws governing the cosmos to the principles behind everyday devices, his legacy is all around us. Newton's story is a testament to the power of human curiosity, the importance of questioning accepted knowledge, and the enduring impact of scientific discovery. As we continue to explore the universe and push the boundaries of technology, Newton's insights will undoubtedly continue to guide and inspire us for generations to come.